The next class we're gonna have is balloon science. What is balloon science? Because I do love balloons. I like super in love with balloons. Every time I see balloons, I must take picture with them. And then it's very festive. I have them for all my parties and festivals and so on. But what is science has to do with balloon? Mm, all right. So what is science have to do with balloons? I'm not quite sure, but it's exactly like the bricks for kids. I didn't know what I'm gonna learn, but I enjoyed it. So I am looking forward for the next session as well. So the next session we have Keto Science Makota Charas. So Keto Science Makota Charas is actually a center which focus on hands-on science experiment for kids from 4 years old to 14 years old. Oh, I like it. 4 years old already learned something cool. What did I do when I was 4 years old? I don't know. Okay, so mummies always have that problem. Sorry, not all mummies, but sometimes, being with kids could be tough. We understand that. So when the kids always ask, why, mommy? How, what are? All these questions, right? Sometimes we'll get parents quite, but then don't worry, because for this class, the experiment class, the teacher is going to answer to all your questions. So if you have all sorts of why, how, what, remember to comment down there later on, okay? You can ask teacher and I will help you to remind teacher as well. Okay, without further ado, let's put our hands together to welcome teacher Bobby from Kido Science Makubacharas. Hello,
Hello, hello.
Bob. Hi,
Hi.
teacher. Balloons with
Sorry,
me already.
I'm flooded with balloons right here. I'm so sorry about it. Today's all the
No,
balloon
that's what
science.
makes me feel so
So,
happy.
so yeah, there's a lot of balloons all around me right now. So, well, good morning, everyone. Good morning, Jolie. Very nice to meet you. Thank you very
Okay.
much for bringing me in. All right. My name for
You're
those
welcome.
that are is right here in the morning. Good morning, everyone. My name is Teacher Bobby. I am from Kiddo Science, Makuta Cheras. All right. So if you are here new today for Go Kids and for Grow Special Learn at Home Fest, it is actually balloon science today. So it's everything to do with balloon
Yeah.
science. So, and anything that you have ever thought that we can do with a balloon, I will show as many experiments as I can with balloon today. If you happen to have a balloon yourself, Joey, you can actually go along with me also if you want to.
Yeah, I have been
Right?
looking for balloons at my home, but unfortunately, I don't have any.
No
But
worries.
no
You
worries,
can always
I'm
try.
sure kids will enjoy your class.
Yes.
So, teacher Bobby, are you ready for the class? Yes, right?
Um, I guess I am. I guess I am. Is everyone ready for the class?
I'm sure they are too. So, if you are ready for the class, remember to comment below, and I am going to find my balloons. All right? I'll
No
pass the
problem.
screen to you, teacher Bobby, and I'll see you later.
All right. Thank you so much, Jolie.
Bye bye. Bye bye, everyone. Please comment, and I'll see you later.
Okay. So, good morning once again, everyone. My name is Teacher Bobby. If you are new to this channel, this is going to be the Learn at Home Festival with Google Kids. And the best part about this is you can get to learn a lot of things from science to art to, we just had Lego, everything like that. So thank you very much, Google Kids, for actually bringing kiddo science into the loop. Today, on my part, you are going to be learning everything to do about science, but something which is very simple and can be found at home, which you will always play it every now and then. And one or two of them have to do with balloons. All right, who likes balloons? Who loves balloons? If you like balloons, let me know. Put in the comments if you like if you like balloons, if you like to play with balloons. Yes, tell me that you love balloons, all right? And then I will get started with all the experiments, okay? Now? So if you need to prepare some stuff on your side, if you need to prepare balloons on hand, you can always get it right now. So while I'm actually getting my pictures up for you to see so that I can actually show you what to do and what to prepare, you can actually go and find your balloons first, okay? Now? All right? Quickly go find your balloons first. Okay? All right. So let's see. Okay, so today for balloon science, all right. Okay, so if you guys are having any issues, you can always put it into the live comments there. If you need me to repeat something, yes, you love balloons. I see. Yes, everyone loves balloons. I love balloons. The best part of balloons is they're so colorful and they make a lot of noises. I will tell you all about it later. Okay, now, so for those that actually watching this video right now, if you have any problems with what I'm doing, just type in the comments. I'll repeat it and then I'll show it to you once again. Okay, now. So I will have a shared screen here, all right over here. This will actually help you to understand what is going to be happening, what is going to be taking place. But the main video is right here, okay? Everything is going to be done in front of me. This is going to be the one that's going to assist you with what is Teacher Bobby talking about, everything like that. All right, everyone, who's ready for it? Who's ready? If you're ready, I'm going to start right now, okay? So the very first thing that you'll be needing, of course, is the balloon. Okay. So if you have not blown a balloon up, let's try. Don't blow it up first. Don't blow it up first. I need you to prepare a balloon. All right, and coins. All right, coins. Okay. The best coin to actually have for this experiment is a 50 cents coin. All right, 50 cents golden coin. All right, if you can get this one, this is the best coin for this experiment. Of course, you can use any coin you have, but for right now experiment, if you have it, 50 cents coin. All right, if you don't have 50 cents, no problems, 20 cents is fine also. Okay, all right, so I'm going to, if you have the coin and the balloon, let's start very simple. First experiment of the morning, let's start really simple. Balloon and a coin. Now, put the balloon in the coin. All right? Be slowly, be careful with it. You don't tear your balloon, okay? So, put the coin in the balloon. See this? Now the coin is inside the balloon. All right? Everyone got that done? Excellent. Then, time for you to, all right, you can actually blow the balloon, which I'm used to blowing the balloon, but if you have a hand pump, pump it. If you have a foot pump it. All right, if you have a balloon pump, even better, but otherwise I'm going to do the old-fashioned way. Okay, now I'm going to be doing the old-fashioned way, and let's blow this balloon up. Okay, now medium size to a big, all right, size of balloon. You can do it medium size, you can do it medium, big size, as big as your head. Let's do it together, right? You see the coin inside? All right. Is this balloon big enough or not? Is this balloon big enough? It's as big as my head. Okay. All right. This is where you can get mommy or daddy to help you if you need. You're going to have to tie it up. Okay. Make sure you tie it up. Otherwise, the air is going to come out. So we don't want that. All right. Everyone got that? Everyone got that? Okay. Excellent. If you got that, okay, so now let's try to hold the balloon in one hand. If you can't, two hands is fine. One top, one at the bottom. Okay, so we're going to be shaking it. Do you hear the coin inside? You hear the coin bouncing, making a lot of noise inside, right? I told you balloons make a lot of noises inside one. Now, watch what happens. Everyone, if you can turn your volume up right now, I'm going to let you hear something that's actually happening to the coin inside. All right, turn your volume up right now. So this is the sound of the balloon with the coin bouncing inside. Okay? Okay, so it's bouncing. Now, I'm going to do this. What's happening inside? I'm spinning the coin inside. Try to spin the coin inside. I'm not sure whether you can see in the video. You can actually see something moving inside. Try to spin the coin. So swirl your balloon this way. Turn it. Try to spin the coin that's inside. And then it should make this sound that I'm making right now. You can hear it? Can you hear it? All right. What is happening to the coin inside? Okay. What's happening to the coin inside? So if you hear carefully, if you see carefully, you get to see the coin spinning and spinning and spinning. All right, it's slowly spinning and spinning inside. You can see it on the video. All right. Fun sound? Was it a fun sound? It's still spinning. It's still spinning. It will only stop spinning after a very long time. Okay. What is this? What's happening? What is the science behind this thing? Right? Let me tell you what's actually happening. Something called a centripetal force is actually taking place. What it means is the coin, when you spin it, when you spin the coin inside, the forces will actually, there is a certain force that's actually pulling the coin into the center of the balloon, which is why it makes the coin go round and round and round and round. And the only reason why it will slow down is because of something called friction. Okay? Friction is what happens when you take your hand and rub together. That's heat. And it gets very, very difficult to rub after some time. Okay? So that's friction. But centripetal force is what makes this coin spin round and round. And if you notice, my hand is moving, correct? Now my hand stops. And the coin is still moving. Because there is something called centripetal force inside the balloon that is pulling the coin and say, come on, spin it, continue spinning and continue spinning. All right? So this is called centripetal force. This is actually really, really fun when you put one coin, but let me tell you something. You can actually put 2 coins, 3 coins inside. You can put so many coins inside, and I'm going to challenge you guys. All right, I want to know how many coins you can put into your balloon and try to make them all spin, as in all are spinning. Yeah, we're not going to have one that's sitting down and I don't want to spin. No, we're not going to do that. Okay, we're going to have to make every coin inside there spin. Okay. Try it out. If you have a video, you can always take a video, ask somebody to upload it to Google Kids, or you can actually upload it to our Facebook or Instagram also. All right. I'm not going to do that video because I'm going to challenge you guys to put more coins in the balloon and spin it. And I want every coin to spin. I want to hear like that. I want it to make a lot of noise. Balloons make a lot of noises. All right. We're going to be experimenting with many more noises with the balloon later on, okay? But speaking of centripetal force, you can actually watch a video. I'm not going to show you the video right now because it's going to take a long time. But if those that are watching this one, if you want to find out how is this actually done in the real world, okay, you can actually have a look at something called the motorcycle in a cage. They give you the perfect example of centripetal force. All right, Christine, you only have one, no problems, find more. You can find a 10-cent coin, you can find a 1 cent, 5 cents coin. All right, no problems about that. All right, so for those that want to know what is centripetal force and how does a balloon and a coin become like in a real world, go to YouTube, find motorcycle in a cage. This sport is really dangerous, but inside a cage like this balloon, the motorcycle will go round and round, upside down and all around like that. And then imagine you have one motorcycle, it's fine, like this coin. You only have one coin inside, it's fine. Remember my challenge for you guys? My challenge for you guys is to have as many coins as possible. Just like it's a challenge for these people to actually have more than 10 motorcycles in a cage going round and round, no accidents. And it's all because of science. It's something called centripetal force. All right, guys. It's still spinning. It's still spinning. You can actually see the coin, can you? All right, you can see it slowing down. Yes, that's the coin that's dropped. Okay, guys, are you guys ready for the next experiment? All right, the next experiment is something like magic. All right, science and magic, more or less the same. Okay, next experiment is something to do a little bit like magic, which you will also still need a balloon. Okay, so if you have this balloon, you can use it back. But since I've got so many balloons around here, I'm going to blow a brand new balloon up. Okay, I'm gonna blow a balloon. I just exploded a balloon. All right. Balloons make a lot of noises. I love it. Okay, so for the next experiment that I'm going to be doing, it's something a little on the magic side. Okay, nah? But this magic, I'm not going to call it magic. I'm going to call it electrostatic force. Okay, so for this experiment, what you'll be needing is, okay, don't take this color. Let's take this color. I've got too many balloons running. I like green. Okay, electrostatic force. So what is electrostatic force? You got your balloon. I need you to prepare this. If you happen to have a piece of paper, any rough paper will do. Don't take mommy or daddy documents, okay? Don't cut them. Mommy's going to be so angry. Okay? Take a piece of paper, rough paper, okay? That you're going to be, why you need a rough paper is because you will be cutting it into small pieces. Like really small pieces. I'm going to show you an example of how small I'm looking to be. This small. Okay? If you can't see how small it is, let me give you an example. It is your fingernail size. All right? As small as your fingernail, if possible, smaller. The smaller it is, the better it is. Okay, now? So I want you guys to cut. Just cut. All right? Don't worry about it. Just cut. So what you're gonna do is you're just gonna take a piece of paper. Okay, you're gonna cut. All right, just cut all the small bits of paper. Okay, well, you need quite a number of small pieces of paper. Okay, just cut away. So this is going to be something like a magic show. You know, you can show your mommy, you can show your daddy, you can show your auntie, uncle, like that, and your friends even. Okay. All right, once you have cut already, once you have gotten some of the cuttings already, okay, what you'll be doing is you have to put it on the table. Okay, I'm not going to put it on here. I'm going to put it on this so that you can actually see it. Okay, I'm going to put some on top over here. Okay, let's see if I can collect this all up. Okay, so maybe I put a little down a bit. Okay, so you guys can actually see the paper right now. Okay, can you guys see the paper? Maybe I can get my assistant to actually can you like remove sorry guys, can you remove the teacher Bobby down there? I think everybody will know my name already, so that everyone can get to see the bottom part of the video. Yeah, maybe you can remove that banner at the bottom there. Is it possible? If it's not possible, it's no problems at all. All right. Okay. If you can't remove it, it's fine. Okay. So can't see. All right. Can you actually see the papers right now? I've got quite a number of papers over here. Can you all see the papers? Can you all see it? Can you all see the paper over here? Everyone can see the paper? Okay. Hold on now. Let me try and remove the what? Okay, never mind. I'll try to hold it up as long as possible for you guys so you can actually have a look at it. Okay, so the paper has to be like this, you know, loose. Okay, everyone, so far okay? All right, can see already. Excellent. Okay, I'm going to try my best so that everyone can get to see it even clearer. Okay. Okay. So I think this is the best that I can do. Okay, what's going to happen is you're going to take the balloon. You can take the balloon. I think all of you have seen the experiment where you use the balloon to rub against your hair and the hair will stand, right? Teacher's hair is a bit short, so I won't be doing that, but you can actually do that. Take the balloon and rub behind your hair, like this. And then you put it onto your hair. You can get to see your hair moving. I'm not sure you can get to see or not. Okay, you can actually try this back at home. Okay, now, but today's experiment is not about that. I'm going to do even more powerful force. All right, just like Star Wars, I'm going to use the force. I'm going to use the balloon to pick up the paper. Okay, so right now you see, if you look at this, look at this. Can you see the balloon and the paper sticking? Am I sticking the paper? No, right? The paper is not sticking to the balloon. Am I right? Now, get a woolen cloth. Okay. A woolen cloth. Okay, what is a woolen cloth? If you guys ask me, a woolen cloth is one of the, especially if you have a blanket. If you have a blanket, those type of furry blanket, or you have a jacket, a woolen jacket, that is perfect. Okay. If you don't have it right now, no worries. Have a look over here. Look over here first. Then I can actually show you what's going to be taking place, and then you can actually go get it later and try it. Okay, now. So what is going to happen is you're going to take the woolen cloth and you're going to rub the balloon. Give it a good rub, like you're rubbing rubbing my hair like that. Okay, what you're going to do is you're going to be rubbing the balloon. Rub it, just keep rubbing it. Rubbing it. Keep rubbing it. Rub it until it's really clean. Do you think it's going to be clean? All right, rub it until it's really clean. Ah, the banner is gone. Excellent. Okay, so everyone can get to see now already. Okay, are you all ready to see what happens with the balloon now? Watch what happens. Oh no, how do I get this down? What's happening? It's stuck to here. What's happening to this balloon? You see, it's stuck. But just now it wasn't stuck. What's happening actually? Okay, this is the side. This side I haven't rubbed it yet. Okay, well, this is what happened. Okay, I'm gonna go even closer for you guys. Watch what happens. Nothing's happening, right? Okay, now I'm going to not change my hand. I'm going to rub now. Watch what happens. I'm going to rub. I'm going to rub it really a lot. Rub a lot. Okay, are you ready, guys? Are you guys ready to see that? Okay. So if you guys want to do this as a magic trick for your mommy and daddy, don't show mommy you're rubbing this, yeah? Do it somewhere else. And then you say, mommy, just now the balloon couldn't stick the paper, right? Couldn't attract the paper, right? Now watch what happens. Okay? Watch what happens. And you see the paper all standing. All right, guys? Cannot? All right. If you cannot, there are a few things that it's possible. Okay. If you cannot get it done, there's a few things that's possible. Number one, it is the cloth that you're using. That's why I say try to use a woolen jacket. Ask mommy to find something woolen. Woolen is like those furry cloth that you have. Okay. Number two, rub it. You have to really rub it. Otherwise, if you don't rub it enough, then the electrostatic force is not there. All right, guys. Okay. So I'm going to explain a bit what is actually happening. Okay. So what's actually happening is just now with the balloon. Let's say this side. This is the side where I rubbed it. This is the side that I didn't get to rub it yet. Okay. Okay. So on this side over here, the balloon has what we call charges. Okay. We have positive and negative. Positive is a plus sign. All right. Negative is the minus sign. Okay. So the balloon will have a lot of charges inside. What happens is when I rub the balloon, when I rub, the balloon now has what we call only positive charges over here. Okay. So it's very important to know that positive and positive, if two of them come together, what will happen? Positive and positive will move apart. It will repel each other. The same thing goes for a magnet. If you guys know, if you guys love magnets too, North and north, when you put them together, it will move apart. It will repel. But if you have one positive and one negative, what will happen? What will happen? What will happen? It will attract to each other. So what's actually happening right now is, because I only want positive here, I'm going to use this cloth to wipe away the negative. Wipe away. Wipe. And the paper over there has positive, has negative. So I'm going to wipe off this negative from here. There's no negative now, so it wants to attract the negative. So that's why the paper will get stuck, because the balloon is saying, come on, negative, I want you. All right? This force is called electrostatic force. All right? Electrostatic force. In other words, you can actually show mommy or daddy, mommy, you see, I have invisible force. Okay, but yes, this is electrostatic force. Electrostatic force is a force where the positive will attract the negative charges. Okay, the same thing. Yes, actually, I'm looking at the comments. Yes, you can try with your hair. The same concept. If you have seen videos where people will rub on their shirt and then put next to their hair and the hair stands, your hair is the same as this paper. Your hair will have negative charges. The balloon, after you rub it on a cloth, you put it, the balloon, which is positive, will try to attract your hair. All right, but remember, guys, your hair must be dry. If it's wet, it won't work. Okay, okay? No worries. Don't worry about getting it. You can always get the balloons another day and try it at home. Okay, don't worry about not having it right now. Okay? So for those who actually try it, you can try as many as you want. Use different balloons. Try to use a woolen cloth. A woolen cloth is very important. This is very, very important. Okay, and the most important thing is, if you notice, teacher's paper is actually quite long and thin. Long and thin is actually best, just like your hair. Okay, guys? So remember, guys, invisible force, this is called electrostatic force using a balloon. You can actually do the same thing with your hair also. Rub against a cloth, put next to your hair. Or if some of you boys, you got hair like teacher, you see, like that, you can actually do the same thing too. Watch what happens. I'm going to rub this side. Okay. I don't know if you can get to see it, but I don't think so you can get to see it. It's not easy to see it, but you can get to see the hair all standing. Okay, you can try it back at home. This is really, really a fun experiment. Try it. Okay, guys, let's move on to the next experiment. We have a few more in store. Okay, guys, I'm going to keep this one side. Give me a moment. Oh no, there's so many balloons around here. Okay, so next up, we have, all right, so if you actually look at this picture at the side there, what's actually happening is, like I said just now, the paper will go upwards and it'll get attracted to the balloon, which is the positive side. All right, guys? Electrostatic force. Okay, let me readjust my camera a bit. Okay, so that you guys can see my face. Okay, so for the next experiment, this is the part where it's going to get really, 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 really fun. All right, how many of you, before I continue, how many of you have burst a balloon before? How many of you have burst a balloon before? Like just now, teacher, you can actually hear boom. How many of you have burst a balloon before? How many of you? If you have, put a comment and say, me, I've burst. How many balloons have you burst? Have you burst 100 before? Have you burst 50 balloons? 10 balloons? How many balloons? Put me and then put the number beside, 10 or 15 or 100 or gazillion or a million, you know. Put in the comments. Let me know. So many. Yeah, Jolie, I know you surely did burst a lot of balloons in your time. Really playful of you. Okay, I'm gonna grab a new balloon. Okay. A lot of people have been bursting balloons, right? Well done. Okay, so for the next experiment, this is going to be a bit dangerous. So for whoever is actually doing it, I'm going to be using thumbtacks. All right, you can actually find this in your mommy's house or mommy's stationery drawer. You can actually get it. Okay, don't hurt yourself when you're actually using it. It's really, really sharp. But I'm going to show this to you. Okay, this is the part where, okay, going to use my trusty tray. I'm going to show you what's actually happening. Okay, so we actually have thumbtacks all around here. Very dangerous. Be careful with it. Okay, but I don't want too many. I only want one. Okay, so my question for everyone over here: if I have this balloon and I put it on top of this thumbtacks, will it burst? Will the balloon burst? Who said it will burst? Who said it will burst? All right. Who said the balloon will burst if I poke it on top? If I use this, if I put the balloon and push it against the thumbtacks, who said it will burst? All right. I see some of you say definitely it will burst. Yeah, of course, Liam, it will burst. You know what? Science is all about experimenting. I don't believe it will burst. I'd say maybe not. It won't burst. Okay, let's try it out. Science is all about experimenting. Okay, only by experimenting can you know whether it will burst or not. Okay, let's try it. Let's try it. Okay, one thumbtacks. Experiment. Burst or not? Let's see. Oh my God! I got a big shock. Oh my God. All right. So, of course, it will burst. Right? Of course, it will go burst because this is very sharp. Do you see how sharp this is? Right? Of course, it will go burst. So, let's do another experiment. I'm really excited right now. So, if one thumbtacks can burst a balloon, what if I put more thumbtacks? What if I put lot of thumbtacks over here? Do you think it will burst even faster? Do you think it will burst even faster? Let's try. Let's try. I'm going to put a lot of thumbtacks over here. Okay? Let's see whether it will burst or not. Okay? All right, let's take another balloon. Oh my God, I've got so many balloons over here. All right. Red balloon this time, just like the picture over here. Okay? All right. So who say it will burst now? Who say it will burst even faster? Who say it will burst even faster? Who say it will burst even faster? All right, let's try with this balloon. Okay. Oh, it's scared right now if it bursts again. Okay, let's try. Are you all guys ready to try? Experiment number 2 with the bursting balloon with more thumbtacks. If you cannot see how many, it's not one. I think there's around 10 over here. Okay, watch what happens. Why is it not bursting? These thumbtacks are it's moving a lot. Okay, if you guys want to try it back home, you can actually do what I'm going to show you. I'm going to show you something that I've made so that I can show you guys better. This is a tray of very sharp thumbtacks. Okay, just use a cardboard and do it so that the thumbtacks won't move. Okay, now? So I'm going to try one more time again. I'm going to push it really hard. Okay, this is pushing it very hard. Okay, now I'm going to try. It's very sharp, if you can actually see it. Okay, very sharp. But I think I pushed it too hard. But why wasn't it bursting just now? Why wasn't it bursting just now? Why wasn't it bursting just now? So if I actually have so many thumbtacks, so why did it burst even faster? Just now when I use one thumbtack, when I put on top, it boom, really fast. But when I use so many, why did it burst faster? Why didn't it burst faster? The word is actually pressure. Okay? I'm going to teach you guys a new science word called pressure. So what is pressure? Pressure is force. Okay? that is force. Oh, that is force. Okay, oh, that's also force. Just the same way as this is also force, pushing force. Okay, right? So what's actually happening is, to explain this even better to you guys, let's try this experiment. Let's don't use the balloon right now. Let's just use your hands. Okay, just use your hands. This is a palm, which is like the balloon right now, and this is your finger. Use one finger. All right, and poke it. Poke your finger. Push really, really hard. Do you feel pain? Does your hand feel pain? Your hand will feel pain, right? One finger. But now you use 5 fingers. Use 5 fingers and you push it on the same place on your palm, like this. Not so pain, right? You will feel pressure. You will feel force being pushed into this hand. You will feel it. That's called pressure. But is it pain? Is it very pain? No. But compared to one finger, ooh, it's a bit pain. Yeah. Same thing goes with the balloon. If it's only one thumbtacks, the balloon will feel so pain, boom, it will burst. All right? Just like this balloon over here. Okay? But because I put so many thumbtacks over here, just like your palm and the 5 fingers, it won't feel so pain. And because it won't feel so pain, it won't burst faster. It won't burst faster. But of course, why did the balloon just not burst even though I used this? Because I think I was pushing it a bit hard. Just the same way as if you use 5 fingers on a palm, you push it really, really, really hard, you will also still feel pain, right? But of course, not as pain as one finger, correct, Anna? Okay, so this, guys, one word from science is pressure. Okay, you can actually do more. You can actually do a bigger platform, a bigger cardboard, the thumbtacks. Be very careful, it's sharp. And then you can actually take balloon and try. See? You can actually take the balloon and try and see how many thumbtacks will it burst and how many thumbtacks will it not burst. All right, guys? So remember, guys, pressure is very important. Pressure applies to a lot of things. All right? You can use pressure to actually, for cooking, for actually doing work. All right? Even on the road, there's a lot of pressure. Just like how mommy pump pressure into the car tires, pump air into the, that's also pressure. Okay, guys? So if you want to try it at home, remember this is very dangerous, thumbtacks. You can always try it. But the word to learn from this experiment is pressure. Okay, guys? I've got another last experiment for you guys, and it's actually going to be quite interesting for you guys. Okay? Quite interesting for you guys. I'm going to keep this one side because we're not going to be using all this already. This time, we're going to do a little chemistry. Who likes chemistry? Do you know what chemistry is about? Okay? All right. So for the next experiment, of course, you will need... you need balloons, of course. You still need balloons. All right? You still need balloons. Today is all about balloons, okay? You still need balloons, but you'll need a few chemicals, which you can find in your mommy's kitchen, okay? So the very first thing you'll need is, if you have a bottle, empty bottle, you know, the bottle of water, mineral water, okay? Mineral bottle water. Get a bottle, empty one. A small one will do. I don't want those really, really huge Coca-Cola bottles. No, we don't want that. We only want a small one, okay? Take off the cap. If you want, take off the wrapper also, okay? So keep it nice and clean so you can see what's happening inside, okay? Next thing you will need, the next thing you'll need is, if your mommy has this is called a measuring cup, all right? It helps you to measure how much you're going to pour, okay? So if you have a measuring cup, good. But if you don't have a measuring cup, I have an alternative for you. You will need a big spoon. You know, where your mommy or daddy eat rice with it. Okay. Speaking of spoons, you will need two types of spoons. If you're using spoon and you don't have a measuring cup, you will need two types of spoons. One big spoon and one mini spoon. All right. Big spoon, mini spoon. Important, okay? You cannot use the same thing, the same spoon, huh? Okay. Now for the chemicals we're going to be using is, first, we're going to be using vinegar. All right. I don't have a small bottle of vinegar, so my vinegar is this big bottle of water, big bottle of vinegar. Okay, now, but you'll be needing vinegar, which is very important. And the last thing you will need for your chemical is baking soda. All right, you will need baking soda. Okay, everyone got that? So you will need vinegar, baking soda, bottle, empty bottle, measuring cup. If you don't have a measuring cup, no problems. You can get a big spoon to replace your measuring cup and a teaspoon. Okay, so I'm going to show you guys. If you guys don't have it now, no problems. You can replay this video again and you can redo it back at home. Okay, now, so let's start with this experiment. Let's start by taking a balloon. Let's take one balloon. Let's say this balloon. Okay, I've got a green balloon. Don't blow it up. We don't need to blow it up. Okay. All right. Okay, now maybe let's take an orange balloon. Okay, what you're going to do now is, this is the part where you can ask mommy or daddy to help you, because this is going to be a bit difficult. What you need to do is you need to open the mouth of the balloon big. Why? Is because you're going to take 2 teaspoons. Okay, you're going to take 2 teaspoons of baking soda. All right, 2 teaspoons. Okay. Okay. Don't have to be too full, but the most important is 2 teaspoons. Okay. 2 teaspoons of baking soda inside the balloon. All right. So it's inside. Clean it a little bit. Okay. So keep the baking soda one side. Now keep the balloon one side. Okay. We're going to use it later. Now, if you have a measuring cup, 50 ml. If you can see, 50 ml of vinegar. But if you don't have a measuring cup, 8 tablespoons of vinegar. 8 to 10 is fine. Okay, I'm not sure how big your tablespoons are, but 8 to 10 tablespoons. Okay, this is the big spoon. But since I got a cup, I'm gonna get some vinegar over here. Okay, 50 ml. All right, 50. And then what happens next is very simple. Pour it into the bottle. Don't spill it. You don't want to spill anything. Okay? Okay. This part is where it gets really, really interesting. Do you see the picture beside here? You can see that red color balloon on top. I'm not using red, I'm using orange. But what you're going to do is you're going to wrap this balloon around the bottle. Like this. Does it look the same as the picture beside? Does it look the same? Okay. Baking soda is inside here. Vinegar is inside here. All right. Okay. So what you're going to do now is very simple. All you need is just leave it on the table. And we're going to tip this balloon upside down. What do you think will happen? What do you think will happen? Before I do that, what do you think will happen? If you guys know the answer, quickly comment in the comment section below. Liam says boom. Who says boom? Did you boom? If it booms, I better sit back a bit. I better stay back a bit. Better cover my body up. Will it boom? Who say it'll boom? All right. Let's remember, science is about experimenting. It's about trying out experiments, okay? You guys really like boom, 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 huh? Boom, blow. No. should I cover my face? Vinegar over here is not good. Let's try it out. Experiment of vinegar plus baking soda. Watch. I'm not blowing anything. How is it becoming bigger? Whoa! What's actually happening? What is actually happening? Yes, vinegar plus baking soda will create a certain gas. Okay? The chemical reaction, that is the word we all use in science, the chemical reaction between vinegar and baking soda will not exactly blow up, boom, the balloon, but it will inflate the balloon. Just like how I blow it, just like how you use a hand pump, it will create gas, and the gas is actually called, for those who guessed it, carbon dioxide. Okay, carbon dioxide is a gas. It's not really dangerous, but carbon dioxide is one gas that every one of you will have confirmed heard it before. Where is carbon dioxide found? You will ask. Who has opened up a can of Coca-Cola or a can of 100 plus before? 100 plus of Coca-Cola. Who has done that before? All right. When you open a can, that is carbon dioxide. All right. But of course, those are factory. They all pump the carbon dioxide inside to help keep the drinks nice and fresh. Whereas this one is a chemical reaction where you can actually create your own carbon dioxide. All right. So these are all the experiments with a balloon. There are so many more. I wish I can share them with you, but we're almost out of time already. We're almost out of time. But I hope you guys actually enjoyed all the experiment. Okay. But before I actually leave, science in our class at Kiddo Science, we always like to do this. We actually like to do a recap of everything that we have learned today. Okay. So the very, very first experiment that we did was, I don't have that wong sound, but we did centripetal force. Okay. That is the part where we spin the coin inside the balloon. All right. And then we have electrostatic force, which is the magic one, where you stick the balloon on the paper. The third one is the pressure, where we try to burst the balloon with many, many thumbtacks, but it won't happen. And the last one is learning about chemical reactions, and it is carbon dioxide. All right, guys. Okay. So I actually want to show you guys one last thing before I make a move. Okay. Now I've got something prepared for you guys. Hopefully, it will be good for you guys to actually inspire you guys. Okay. And I'm gonna make another inflatable balloon. All right. Okay. I'm gonna be doing this. Before I make a move, everyone, thank you very much for joining me, Teacher Bobby, at our Kiddo Science classes. Okay. So I hope you guys enjoyed all the experiments. But before I make a move, I want to show you guys one last thing. Okay. I've got two prepared right now. And before I make a move, this is Teacher Bobby telling you guys, have fun with science. And hopefully you guys will be inspired by doing more and more experiments. Okay? So this is the month of May. Happy Mother's Day to all the mothers and mommies out there. And this is all from Kiddo Science, Google Kids, and AlphaGrow. Thank you very much. This is Teacher Bobby. This is where I think I sign out. Okay, guys? So remember, guys, science is we are from Kiddo Science, and you have just watched Teacher Bobby.
Thank you, Teacher Bobby. Hello, I love your session so much.
Oh well,
Oh,
I'm glad you loved it. If only you and I were in the same room, we can actually do even more balloon experiments because two-person doing
yeah.
balloon experiments. If one person can make balloons burst, imagine what two-person can do.
Woohoo! I really love it.
Yeah.
And then I love how you also recap the whole thing because I was being a good student. I actually did jot down all
Ah.
the centripetal force and so on, but then I didn't expect that, oh, you actually recap everything.
Yes, yes.
Oh,
At Kiddo Science, we actually like to do this because learning science is fun. But that's the thing. Kids being kids, they will feel it's really,
mhm.
really fun. And after the fun is over, what was it again? What's that word again? Huh? I was enjoying so much just now, but I forgot what the word is. So we always like to do this
Ah,
recap and everything like that. So yeah, this is how we actually work at
mm.
Kiddo Science over here.
Yeah, I like how you put the fun and also knowledge together. And then I love one of the quote that you said as well. You said science and magic more or less the same. I like
It is,
that,
it
which
is.
is very
Uh,
true.
It is actually quite true when you actually ask magicians, because magicians will actually tell you magic is all about it's some of the magic, especially the ones that have to do with chemicals, everything. It's just it's science. Magic is science that you don't understand. Oh, that's what I was told.
Mm.
So if you don't understand why today the sun comes up, then later on the moon comes up. Then sometimes I see the moon. Sometimes many years ago, people were taught that it's magic. I think something of the higher beings actually, things like that. The
Yeah.
balloon bursting, it will be like magic, but you don't know the reason behind it. That's why it's called magic. But once you understand it, then it becomes science already. So
Okay, so right, Teacher Bobby, I have one question here.
yes.
Because right, just now you showed us the electrostatic force, and then I
Hmm.
always wanted to try something like this, which it failed. See? So does it have to
Ah.
do with the static thingy as well?
Okay, so what will actually happen? This one is actually, I believe what you're showing me right now is balloon with a lot of paper flakes inside the
Confetti.
balloon. Confetti, yes, that's the word
Uh-huh.
I was searching for. So what actually happens is you can actually try to inflate the balloon up, okay?
Mm-hmm.
And then the paper has to be as dry as possible. And then from the outside, you can either do it you can find a really, really, really woolen cloth and rub the top. Don't start at the bottom because
Uh-huh.
the paper is at the bottom. So you rub it on top and then you start shaking it. While
Oh.
shaking it, whatever charges that it can be collected, it will collect by the cloth. And then once the balloon is only filled with positive charges and the negative charge being taken by the woolen cloth, you shake the confetti to release all the negative charges and the confetti will move upwards.
Oh, okay.
What
Thank
actually helps
you.
is you take the balloon and you can shake and shake and shake and shake and shake. It also helps, but not always. It won't work as good as if you use something woolen to rub it.
I
Of course.
see. Because actually I have tried a few times, but it
Mm,
it didn't go well because all the confetti just like fell at the bottom
yes,
part.
yes, yes. There's
Mm.
also a chance that the balloons that those party shops they actually use for all this. There's a possibility that the balloons is a special type of balloon that they use, and
Oh.
the air that they pump inside, it could be a machine generated air, not our like that. Okay, so it's machine generated. So most probably the air is a bit cleaner inside, and it's not so much charges on the inside. So a lot of things that will
Oh.
affect it. That's why most of the time, if you notice their balloons that you actually buy, their balloons are way thicker than this.
Oh,
They are very, very
yes.
thick. Not like these. These
Um,
are typical party balloons, but their balloon is
all right.
transparent and it's a bit tougher and it's a bit thicker. So yeah, something like
Okay.
that. Hopefully that answers your
So
question.
yeah, definitely. I'm gonna try it again. And then
Great.
there's another question, right? Speaking of balloons, so if I would like to try all these experiments, right, do I need to like pick a certain type of balloons or any balloons will do?
Any balloons will do. Any balloons. Of course, try not to take those long clown balloons, like the clown like to do. Don't try not to use that because that's a really long and not easy to work with. Try to have something that's a round one, like standard party balloons, like this type. The one that you find if the closest you can find it is KK Mart, because that is my favorite shop to go to find all these. KK Mart
And Mr.
99
DIY.
Speed Mart may not have it. Mr. DIY, yes. But Mr. DIY seems to sell out really fast. I don't know why. Maybe a lot of people enjoy balloons too.
Okay. All right. So kids, right? Here to remind you guys again, just now Teacher Bobby actually gave you guys a challenge, right? Ta-da!
Yes.
So Julie is here to remind everybody again. Remember to do the challenge, which is the Centripetal Force. You put a coin inside and let's see how many coins you can actually spin together.
That's right. That's right.
So remember to record the video and then upload to your Facebook or Instagram and hashtag Google Kids and hashtag Learn at Home. All right. So that
then maybe
Bobby can check.
Maybe you can actually, you can actually hashtag Kiddo Science Makota Cheras also, so that Teacher Bobby can actually get to see your videos also. So I'll just have to type hashtag Kiddo Science Makota Cheras, hashtag Google Kids, hashtag Learn at Home, and I'll see. Oh, okay, so this person has put out a video. Wow, that he put 10 coins inside. Wow. Yes.
And the best part is when you have all the videos together, right? You get to see the colorful balloons like putting next to each other. It's gonna be
that is something I never thought about it. Huh? Good thinking, Julie. Good thinking. Well, very nice, very nice. Okay. All right. So thank you very much, guys.
So much. Yeah. So we hope to see Teacher Bobby again. And if you guys have tried any of the experiment, please share with us. All right.
All right.
Thank you, Teacher Bobby.
Thank you so much. Have a good day, guys. Thank you, Jolie.